If you would have asked me 5 years ago what the on-trend brewing thing would be in 2021, I never would have guessed that hard seltzer water would be so popular. Laugh all you want, but hard seltzer is a fantastic day drinker and likely isn't going anywhere in the near future. Imperial Yeast's new seasonal strain, W04 Paramount, can help brewers get the most out of their seltzer fermentations. A clean and aggressive fermenter, Paramount will produce an excellent seltzer with low fusel alcohols, and it's produced in a gluten-free medium. If you've tried making seltzer with standard ale or lager strains, you know the struggle, and Imperial Yeast is here to help with W04 Paramount. Check it out at imperialyeast.com. Welcome to the Brew Lab. Every bag of malt that you purchase comes with a certificate of analysis. And if you're a commercial brewer, you've probably looked at hundreds of these. And if you're a home brewer, you may have never looked at a single one. But what are the things you should be paying attention to? What are the most important items on a malt COA? I'm your host, Cade, and today in the lab, these are the questions that Dr. Harmonie Bettenhausen and I will be trying to answer. Now, this whole episode spawned out of a conversation that started at the annual meeting of the American Society of Brewing Chemists in June, and Harmonie and I were talking about all of the information on a malt certificate analysis, all the work that goes into it, and we realized we should do an episode on this. We should talk through the most important items on a malt COA, and that's exactly what we're going to do. This is specifically intended to be relatable to brewers of all sizes, from the smallest home brewers to the largest craft brewers. There's a lot of information on the malt COA, and this episode is intended to help you sort through it. We're not going to go through every measurement on the malt COA. We're not going to talk about all of the nitty-gritty details about how it's measured and analyzed and all that stuff, but we are going to go through a few of them. So I've asked Harmonie to pick a handful of the ones that she thinks are the most important. She'll tell us what they are, what they measure, how they're measured, and why even homebrewers should find this information useful. So hopefully this is a great episode and one that everybody is able to relate to. But first, I wanted to say another big thank you to our patrons. None of this would be possible without you, and if you're not currently a patron, I'd love for you to head over to patreon.com/brewlosophy and become one. In addition to the feel-good vibes of helping to support the work we do here at Brewlosophy, you get access to a bunch of awesome rewards depending on the different pledge levels that you choose. You can get access to Brewlosophy contributor recipes that we've never published, new discounts each month at YakimaValleyHops.com, and for $3 a month, access to a monthly live Q&A session with a special guest from the brewing industry. And this month's guest is homebrewing legend John Palmer. This is the author of How to Brew. It's literally the first book I ever read on homebrewing, and it's the book that got me into beer. You all know John. He really needs no introduction, so I'll just remind you that to be a part of this Q&A session, you'll need to become a patron at patreon.com/brewlosophy. And thank you to everyone that's left a rating, a review of the show. I truly appreciate hearing from you, and those ratings help other listeners like you find the show. We're almost up to 100 ratings, I think just 2 away, and without those reviews, we wouldn't have the Applying the Science series with Jordan, so keep them coming. And if you haven't yet rated or reviewed the show, I'd love for us to break 100, so please do so if you get a chance. Feedback is brought to you by the folks from John I. Haas, who over the last couple years have released a handful of really cool hop products like Lupamax, Incognito, and Flex, all intended to improve beer while reducing vegetal matter and thus increasing yields. Well, they're excited to announce their latest 100% hop-derived product, especially made for your patio, lawnmower, or beach beers, Kettle Ready, imparts smooth, light, stable bitterness and kettle hop aroma to beer while offering microbiological protection during the brewing process. This new product is easy to use and has no special dosing requirements, plus, due to its standardized high alpha acid concentration in a light, stable molecule, it gives the light stability and bitterness characteristics desired for all traditional beers, and it plays well with other Haas products, including Tetra Hop Gold, Hexa Hop Gold, and Ready Hop. For flexibility and optionality when brewing light, stable beers, check out Kettle Ready. Learn more about Kettle Ready at johnihaas.com. That's John, the letter I, Haas.com. All right, listener Anton wrote in. He says, hi there on episode 105. Now, episode 105 is Applying the Science, where we talked about beta-glucans and beta-glucanase under different mash regimes. So Anton says, thanks for providing such great content. I really enjoy listening to even the most obscure subjects as they continue to broaden my horizon and are often surprisingly fascinating. On the issue of mash-out temperatures, I would assume the major purposes are to actually denature all enzymes in order to prevent the wort getting thinner or more fermentable, than anticipated, since the enzymes would keep working during the layering phase without a mash out, and secondly, to improve sugar solubility, reducing the amount left behind in the grains, which I always thought is also the reason to heat up your sparge water to around 76 Celsius. Best regards from a fellow food chemist in the making, Anton. Hi, Anton. Yeah, the mash out serves a bunch of purposes. And so, yeah, like you mentioned, one of those is denaturing enzymes to stop the release of more fermentable sugar into the wort. And the higher temperature, like you said, does aid in Vorlauf and sparging stages by helping to rinse out those sugars that are still stuck in the grains. I mean, that's why you like that higher temperature, because it helps to rinse out things from the grains. And that's, again, why we do this whole Vorlauf, sparging, and lautering step, is so that we can maximize our sugar extraction. Now, there's some question about whether a mash out is absolutely necessary, though, and it depends on a bunch of different things. It depends on how long you've been mashing. It depends on how quickly you can get the wort off the grain. And arguably, if you've achieved full conversion in the mash, there's really not much left in the grains to convert. So denaturing the enzymes isn't doing anything because you've already converted all of the starch into fermentable sugars. And I think that's one reason why a lot of brewers are moving away from the mash out. But to answer your question, or at least affirm your comment, yes, doing a mash out step is about denaturing enzymes. It's about aiding in the rinsing out of sugars out of the grain. And it was a pretty cool episode, 105. I know it started about beta glucans and beta glucanase, and then we just started talking about mashing enzymes, which was a lot of fun. And hopefully I can do another show like that in the future. So thank you, Anton, for your comment. I'll be back in a few minutes with Dr. Harmonie Bettenhausen to talk about the most important parts of a malt certificate of analysis. We all know that designing recipes is really fun, and doing it well is so much easier with good software. We at Brewlosophy recently made the switch to Brewfather, and honestly, y'all, we could not be happier. Brewfather utilizes the latest technology to bring you the most robust cloud-based recipe design software that can be accessed anywhere, on your phone, tablet, desktop, and even offline. It also works seamlessly with numerous third-party devices to make it easier to monitor every step of your brew. I know change can be difficult, but trust me when I say you need to go to brewfather.app today to try it out for yourself. That's brewfather.app. Are you opening a brewery, or have you already? Did you know More Beer has a pro division? MoreBeerPro.com is your brewery or brewery in planning one-stop shop for all your brewing needs. From complete brew houses and accessories to fermentation and even cooperage, they've got you covered. More Beer also has the largest selection of malt, hops, chemicals, and other brewing products of any vendor at low wholesale prices, all of which can be delivered on the same pallet, saving you and your brewery even more on shipping costs. Visit MoreBeerPro.com today to sign up for an account and talk with one of their knowledgeable brewery consultants. Back in June, I was listening to Ken Grossman give the opening speaker keynote at the annual ASBC meeting. And if you've heard Ken talk about Sierra Nevada, you'll have heard him talk about quality and his commitment to it. Like all the other guests on this show, making great beer is the goal, and having consistently quality beer is what's important. And his keynote spawned a conversation about malt quality and how there's this weird disconnect where most home brewers have never even looked at a malt COA, and yet most commercial brewers can't live without them. And the person who I was talking to about this is none other than Dr. Harmonie Bettenhausen, who's with me in the lab today. Welcome back to the lab, Harmonie.
Thanks, Cade. It's good to be back.
Yeah, I'm glad to have you back. And being a home brewer, I can honestly say as a home brewer, I never looked at a malt quality COA. I never asked my local homebrew store for it or anything. But when I'm planning research brews, like now brewing beers at Oregon State for science, I have to know the malt specs, right? I have to know what beer I'm actually going to brew. And maybe I'm not the only one having this experience, but I don't know. Have you heard anybody else with this experience?
I feel like you're not the only one. No, I don't think it's something that is addressed enough regarding its importance at all levels.
Yeah. And it was really surprising to me too, right? Like commitment to quality. Everybody says like quality, we want to have quality good beer and all that. I mean, even home brewers want quality good beer. But then you ask them like, what do these things mean on a malt COA? And a lot of people just go, I don't know. I just look at extract potential and that's it. You know, I don't look at anything else. But there's so much information on a malt COA and it all blends into this whole discussion of quality, right? Like, what does it mean? You know, we hear talk about like, oh, malt quality is not as good now as it was several years ago. Well, how do you know? And what does that mean? And so we have in this discussion, we were talking about it there at the ASBC conference, and we said, hey, we need to do a podcast episode on this. So here it is. And Harmonie's back. Harmonie, of course, is the director of the Center for Craft Food and Beverage at Hartwick College. And she's been on a couple of episodes before. Episode 4, Malt Metabolomics, and episode 83, Brewing with Rye. So what's been going on with you, Harmonie, since we last had you on the show?
Oh, so much. Well, you know, we've been at tons of conferences and
Right.
I mean, we're really busy here right now at the lab. It is obviously, we were just discussing before the podcast, it's harvest and we're in the middle of seeing tons of samples from all over the country, all of the small grain samples. So thank you everybody who sends those in. We have several research projects going on as well as our day-to-day. And we're also opening a second part of our lab focused on milling and baking, testing and R&D.
Oh, cool. Milling and baking. That's interesting. So like using small grains as like for commercial kitchens, like milling it and then baking with it, using it.
Yeah. Using, trying to promote small grains education at the very local, like hyper local level. You know, everybody, I feel like people have these experiences where they try to, use a local flour and then they have bad luck with it and they don't ever go back to it. But we're going to, try to do a lot of education surrounding how to use those things and why you should use them.
Cool. And small grains. What do you mean by small grains?
Anything, mostly predominantly wheat, of course, but any alternative grains, barley, rye, oats, any sort of, gluten-free grains. We will be doing R&D and testing and also offering workshops to people who would like to learn to use these grains in baking.
Well, cool. If you're over on the East Coast up in New York, I mean, check this stuff out. That sounds fun, right? Some workshops on how to use these grains in baking. Breads and stuff. I love rustic breads. So that's rye especially is one of those things that one of my favorites to have in bread. And I have this weird kick about bread. I don't know what it is, but I think all bread should have rosemary in it. I don't know why. I just love rosemary. So maybe we could make some rosemary rye or something like that at one of these sessions. But any event, today is not about bread. It's about malt and specifically malted barley. And so one of the things that we wanted to do today with this show is talk about reasons why you should read your malt COA. And that's kind of the aspect that we'll take of the show. But I also wanted to talk about, again, like why you should read your malt COA, but what some of these things mean, right? So what are the most important items on the malt COA? How do you use those in your brewery? What are some easy, calculations or uses that you can use to take these numbers and actually make your beer more consistent and more quality? And the cool application about this show is every brewer uses malt, from the home brewer all the way up to, the giants, right? AB and Miller Coors and Heineken and all the other international breweries. Everybody's using malts, and so everybody gets a malt COA. Everybody's provided this information. The question then is, what do you do with it? And who better an expert on malt quality, Harmonie. So Harmonie, I'm going to ask maybe the most open-ended question I've ever asked on this show, but why should anyone read a malt COA?
Great question. So I guess the overarching message here, the broad answer is, maltsters, brewers, distillers, whoever you are using this, they need to be able to, you need to be able to look at a COA and understand it and use the data. You have to squeeze whatever information you can out of it and know how to look at trends and ask questions. And this means you're using the malt to its fullest extent. Part of the price built into buying malt is the price of the COA. And that's something you're already being charged for. We don't do this for free. And, that is part of, again, the price of, you paying for malt, and millions of dollars a year is truly spent on producing these malt COAs.
Yeah, that's a really good point, right? Most people don't think about that. I mean, again, for home brewers, the cost of a malt bill isn't what it is for some of the larger breweries, but at the same time, yeah, you're paying for it, right? Some part of your of the cost of your malt is paying for a COA.
Yeah, no, exactly. And, the most common thing that we hear, and, we sort of joke about it is, people don't understand, quote unquote, or they throw it away. They've never had the chance to sit down and fully look at and process the information, maybe. But, that kind of makes me sad. It makes me sad because there are teams just like mine that put a lot of effort into making sure those data are, accurate, precise, and available to you on a very public level.
Yeah, I mean, even at homebrewers, they're brewing with brewing software. Most people, right? Most people are using this, and there are spots in the brewing software to input all this information, right? And it'll help you collect or calculate your original gravities and your water bill and all this kind of your water additions, your malt bill, water additions, all this stuff, color, everything that comes from the malt COA, right? And if you're just relying on what's in the program or something as this generic extract potential or color or any of these other measurements that are on there, what are you doing to your beer? Are you actually brewing the beer that you intended to brew? And worse or better, if you try to brew that beer again, is it going to be the same, right?
Yeah, no, that's a great question. And honestly, I just picked up, or it just came, the new brewer, the new brewer, and it is an article about lager, the case for slowing down. And one of the things that one of the first paragraphs says, the trick to making lager is that there are no tricks. There are only techniques rooted in tradition and history, record keeping, and attempts at repeatability. And the thing that really comes to mind is that people like to say that brewing is an art and a science, but you wouldn't have art without science. I'm a little biased,
We should have had you on that episode. Marshall and I on the Brewlosophy podcast did an episode about is brewing art or science. We should have had you on there to talk about that.
I mean, it's truly, at its heart, it is a science. I know that people like to fashion themselves as artists, but, paints are chemistry, photography is chemistry, and physics and engineering and so on. And all of the tools at your disposal as a brewer are based not in absolutes because things do change, but they are based on data and science and experience. You want an outcome. How do you get there? What is your roadmap for arriving at your destination? Are you riding a bike, a motorcycle? Are you taking the bus? How do you know when you've gotten there? The COA is part of that roadmap.
That's a great one too. Yeah. And I like the idea of the artist there too. I think about like photography, right? If you ask photographers, they're going to talk to you about lenses and light most often, right? Those are two things that they're going to say is like, yeah, we're going to go here because I can get the light is good at this time, right? So they're looking at light quality to know that what their photos are, to make sure that their photos actually look great. I mean, it's the same thing here too, right? You're looking at the quality of the malt. You're looking at the different aspects and characteristics of the malt that produce a great beer and a consistent beer. And one of the things too, in talking with you about this, Harmony, I remember is there's also malt specifications for other grains, right? Like rye, wheat, and everybody. They all have COAs too. Maybe not as detailed as malt COAs, but there's something that exists.
That's funny. This was just a topic of conversation between Hannah and I, Hannah at Montana State, who also runs the malt quality lab there. And we, there are COAs, yes, for wheat and rye, and we run other grains as as if they were going to be adjuncts, of course, and you don't get much information on those. But all of the measurements that are made are based on what we do with barley. So, one of the projects that we are working on, and this is a grant that we received in conjunction with Michigan State, my partners over there, James DeDecker, Brooke Wilk, and Christian Kapp. We wanted to learn more about best practices for those, quote unquote, alternative grains, anything except barley. Because yes, there are COAs for them, but what they mean, we're not exactly clear yet.
Right. Yeah. And who knows if you can use the same assays on these grains, but then also the grains are different. And so they might have different characteristics that might be important to them. Right. I'm assuming.
Yeah, no, absolutely. One of the things that we're trying to work on is sort of backtracking. We're working with a distillery who, has already made product. And I'm like, okay, can I get some of that raw grain from you? Because I'd like to understand, the measurements that we get, are they even applicable or relevant for you?
Mm-hmm. Yeah, right, exactly. Are they even relevant for what you're trying to do with the grain? That's a great one. And so that's a little bit of what we wanted to talk about today. And there was a question that came up a while back from somebody that I was talking to. It was in connection with the conversations that I've had with Pat Hayes on like malt barley specifications, right? Because Pat Hayes is a malt breeder, right? He's a malt grower. He's trying to find new strains or new, I can't remember the word, but new varieties of barley to brew with. And so he's focused a lot on these AMBA guidelines, right? The American Malting Barley Association guidelines. But that's not what we're talking about when we're talking about a COA, are we?
Correct. Yeah, AMBA, they maintain a set of standards that are predominantly breeder targets, and of course, you've talked with Pat enough, that breeders need those targets. But this also trickles down into expectations that we have for barley for malting and brewing. But there can be some buffer there. When you get a COA, that's a representation of a sample that was sent by a maltster. If it's raw grains, then then it's from the farmer. If it's malted, then it was sent from a maltster. But that's a representation. Example, we set our protein targets for 9.5 to 11.5%, right? So number one, what does that mean in a generic sense? Say you're Admiral malting in California. What does 11.5% protein mean for them? Is that low? Is that high? Is that normal? Does that change the way it's malted? Does that change the way a brewer will be able to use it? Now what if that's the same grain grown in Michigan or New York or Florida or wherever, And what if the next year that same grain grown out in California is different? What if it's 12.5%? How did that happen? And then you kind of have to keep asking those fundamental questions again. Each variety that we put out there has a different personality, and we have to understand how to use that COA to make quality malt from it, and then communicate that with the brewer and put that in their hands to use that, that information and make data-driven decisions.
Yeah, that's a really good question. I might ask this a little bit later whenever we're talking and diving into some of these things, but how does, let's say that something like that happens, right? Where you've got a protein content that changes year over year, right? I mean, I understand it's going to kind of depend on the thing, but maybe this is a topic we can discuss as we're going through the measurement is what does it mean downstream, right? Like if the protein content changes, does that just mean that year you have higher protein content malt, or are there things that maltsters can do to make changes? But really that gets into a heart of a question, and it's something that you talked to me a lot about, and it's conversations with suppliers, right? It's being able to talk with your supplier and figure out what you need, right?
Yeah, that's an important part of this. We like to encourage people to talk to each other all up and down the supply chain. I realize that there are brewers that have never stepped foot in a field of anything. A lot of the maltsters, especially local maltsters and farmers, tend to work together more closely. But there's a real disconnect then, even between maltsters and brewers or distillers. Some have those conversations, but they're very important. I talk to maltsters all the time, and we have these conversations about, okay, what am I going to do here? I've got this lot of barley, it's got this protein, whatever, that's these characteristics. What am I going to do to make this malt? And I'm like, well, what do your end users want? Are they happy? Have you talked with them? Has there been feedback there? And often there's not a lot of feedback from those situations. And even as far as, a brewer may have tried to use, craft malt, a local malt, whatever, and maybe didn't like it that much or whatever, and never communicates that. And I would encourage all brewers who try anything to really, communicate that back to the maltster. Those are important conversations to have, because that pertains to, that exact consistency and quality that we're talking about, and we would like to improve.
Right. And I think about that all the time, right? If you talked about the craft malt, right? You used this craft malt and you didn't like it, right? But why? And did you use it appropriately, right? Or should you have used it differently? They're not like one size fits all. Everybody talks about two row as the base malt, right? And two row is just inflorescence of barley, right? That just describes, the shape of the barley. So all barley, well, not all of it, but most of it that's used in brewing is two-row, whether that's caramel malt or roasted malt or specialty malts or Pilsner malt, floor malted, any of these things, right? There's like so much variation within two-row, but even like breaking down into Pilsner malt or pale malt. I mean, Harmony, the first episode that I had you on the show talking about how variety itself can influence downstream malt characteristics. So there's all of these different pieces that impact how the malt comes to you, the brewer, if that's who's listening to the show, or, the maltster, how the barley comes to you and what you do with it. And it's important to know that for consistency.
Yeah, absolutely. And understanding those connections and then how to use them, yes, in the brewery is really important. If you don't understand the connections and you're not keeping the data, you're not only keeping the data, but understanding how to use that data and make sense of it, then you're not really getting as much as you can be getting.
Mm-hmm. So I've got two questions before we start digging into some parts of the COA. One is, does a home brewer really need to read a malt COA? So if you're asking like from a very small level, do they really need to know extract potential and friability and protein content and this sort of stuff? It
depends on what you want. We talked about it at the conference, right? Home brewers, number one, it depends on their experience level and what they want and the type of thing that they're brewing with. If they're brewing, with, an all malt instead of a kit or something like that, I would say they need to keep track of those things and maybe start to learn about the specs on the COA. Someone who's brewing from a kit, I guess, no, probably not.
Right,
It's not really relevant in that situation. But it just depends on what they want to know. And are they looking to make something that is consistent? Maybe they brewed a Kolsch or a lager or something that or whatever that they really liked and they want to brew that again. Well, how are they going to know how to get that again if they haven't kept track of, even the basic stuff? If they didn't keep track, what if, next time now they go to the homebrew shop or whatever, and they get something with a completely different protein? Well, how are they going to know if there are changes that need to be made to still, create that same situation with this beer that they liked?
That's right. I think of a great, maybe one instance that homebrewers would understand. It's brewing for the National Homebrew Competition. So there's two rounds in the National Homebrew Competition. There's an initial round that sort of goes through, and then most people rebrew their beer for the second round to send in, to like the finals, essentially. And that's because, it may be 6 months between the time that you brewed the beer originally and sent it into the first round and then the time that the second round happens. So, a lot of brewers certainly aren't sending their hazy IPAs that are 6 months old, to the finals. And so like, that's a great point. We focus on, recipes and spending all this time to make a great beer. But then if you brew it using a malt that has changed, right, since you brewed the first beer 6 months ago or using a different lot or whatever, you might actually be brewing a different beer. And you want to send the one that got you on into the finals. So those things can change. Of course, like you said, Harmony, it depends on the use, right? I think a lot of home brewers have never brewed the same beer twice, right? And they don't care about consistency. They're not submitting their beers to competitions. They're just brewing beers because it's really fun to brew beer. And I think that's awesome. There's also the sciencey home brewer that's just interested in science and just wants to know and collect the data, right? And make these sorts of tweaks. And so the sort of second question, which I think the answer is yes, does a commercial brewer need to read a malt COA?
Yes, and that's, I think, I may be a little biased, but I would say pretty solidly yes. And Campbell Morrissey and I go back and forth on who needs to read those and who doesn't, and what you're gleaning from them. But and we joke about it, but Campbell at Freem, he keeps a ton of data. Every time I talk to him, we talk about data, and we're talking about data. He may joke about it as a commercial brewer, but he reads those very closely. And I would say at a commercial level, if you're not, then you're asking for problems. If you're not able to look back on that and see what's happening, and monitor things like crop changes, year changes, just basic raw ingredients changes, then you're asking for issues, and you're missing out on what you really could be understanding and knowing about what's going on in your brewery.
Right. I mean, there's an example that I heard somebody talk about a while ago. I can't remember who it was, but they said essentially, if you think about alcohol content in your beer, right? If you're selling beer, you have to label the alcohol content in your beer, and it has to be within 0.3% or 0.5%. I can't remember exactly what the number is, but the actual alcohol content in your beer must be within 0.3 or 0.5% of what you label on your label. And if it's not, you can be fined by the TTB. If you have a big change in your malt, and even if you're using, let's say, Weyermann Pils malt, and you've always used Weyermann Pils malt, but if that Weyermann Pils malt comes from a different lot and it's got a big change, you could potentially have issues like that. Now, Weyermann's not the best example because they're going to homogenize and make sure that their malt stays pretty tight. But if you're using a craft maltster and, things change, things change year to year too. So the recipe that you had for last year might not be the same recipe that you brew with this year because crops change. So those are things to keep an eye on. All right. We need to move on and jump into the COA. Otherwise, I feel like we could talk about this topic for the whole episode. But I know people are kind of wondering, what is important then? Okay. If you think I need to read a malt COA, then tell me what I need to know from the COA and what I need to get from it. So the way that Harmonie and I decided to do this is kind of talk through what we think is kind of either like most important, second, third most important, or maybe like the top 3 to 4 things on a malt COA. So let's start with the top one then, Harmonie. What do you think is the most important item on a malt COA?
Ooh, that's not tough for me at all. Yeah. I would say friability. I would say even if you were to, and people, brewers often ask, if there's one piece of equipment or, and maltsters as well that I should get in my malt house or brewery, I would say a friabilimeter. The friability tells you a lot about your malts, about modification and moisture and protein. Friability. Okay. For sure.
Friability. Okay, well, so what is friability then?
So friability is the measurement of, how friable your malt is, and it is a measurement of the modification of the malt. You'll be able to say if you have a malt that is low, has a low friability, like below 80% or something like that, you know that there is something going on with the malt, and it might not be a bad thing. It might just be a high protein malt, but you can also probably tell a little bit about the moisture and a little bit about what is going to go on with your enzymes. Less than ideally friable malts lead to, or sometimes are an indicator of under or unhydrated kernels or dead kernels, things like that. All things that lead to like high beta glucan or low enzymes.
Oh, interesting. Okay, so then friability is kind of a look at how is your malt going to perform, right? It's like, are you going to be able to get what you need out of it in terms of the brewing process? So is that like different than, what about like diastatic power? That's one that I've heard. That's more of like specific on the enzymes. Is friability more of like an overall look at the malt, or?
Yeah, friability is an overall look at the malt. Diastatic power is, just that roughly, it's that measure of beta amylase, which is important in starch and adjunct breakdown. But the friability it's mostly a physical measurement of the friability of your malt. How easily it will break down. And how easily it will yield you what you need.
Interesting. Yeah, because I'd always thought of friability as being like a squishiness factor. It's like how squishy is your malt? But it's squishy like that for reasons, right? Because it's been modified well, because there's the target moisture that's in it, those tell you a lot about the malt itself, that you're going to be able to use this malt for the purposes that you want for. So, how is friability determined?
We use an instrument called a friabilimeter, and it basically spends 8 minutes crushing the malt, and then we measure. That we weigh it in different portions, and from that, again, we can determine how modified that malt is, and depending on the amount of like little half kernels that are in there or whole kernels, those are called partially ungerminated kernels, or wholly ungerminated, the pugs and wugs. And those are, again, indicators of potential dead kernels in there, which will yield you nothing but problems. And then the partially ungerminated are an indicator of potentially something happening during the malting process. Potentially, it wasn't hydrated enough to undergo complete modification. So you're looking at, potentially some high beta glucan and lower enzymes and, just issues down the road, potentially some viscosity or haze issues.
Okay, so how should I use that friability number then? Like, let's say I'm looking at my malt COA and the friability is, I don't know, you tell me, but whatever, like a range maybe that would be useful. Yeah.
I mean, if you have, so if you have something that's, let's call it 80% friable, maybe 75 to 80%, the first thing I would then look on down the line and say, I would know that something was up, for lack of a better word. I would first look at the protein and say, okay, well, is this high protein? Is that the reason it is lower in friability? Is this going to be a high protein malt that I'm going to have to do something different to during the brewing process? And what potentially could this lead to down the line? Will this lead to any, a high fan or high enzymes or, off flavors in my beer? Moisture, this could be an indicator of, high moisture. Too low of moisture is an issue as well. But too high of moisture will lead to low friability. And this also creates, a lot of milling issues. You won't be getting a consistent product through your mill. So that's, of course, an extract issue right there.
Yeah. Uh-huh.
And the under modification, of course, leads to, again, high beta glucan. So you'll have some of those issues, potential lautering issues down the line if you have really high beta glucan because your malt was under modified. You'll have lower enzymes if there was something that happened, if germination was cut short or something happened during germination that cut that production of, alpha amylase short. You may be looking at those sorts of issues. Underhydrated kernels, again, they want to be the goal in malting is to hydrate, just like, they need to carry around a big water bottle or something because the goal is to hydrate enough to stimulate that, the breakdown of protein, the proteolysis, and the cell wall breakdown, and also stimulate those enzymes.
Right. That makes a lot of sense, right? So it sounds to me like friability is kind of a gut check of like what's the quality of this malt that I'm using, right? It's kind of like, should I use this malt at all, or like what's going on with it, right? If there's something else it's kind of like an indicator of, hey, I need to do something else with this malt, other than just like chuck it in my process and not really think about it.
Right. And it's also a measure, of consistency. And this is the same for any metric that we might talk about today. If you have a malt that you're normally getting, from a big maltster or a small maltster or whomever, if you get a malt and it's, consistently 95% fry, something like that, 90 to 95. And then all of a sudden it's 77.
Mm-hmm. Yeah, something's changed.
Something happened, and that's a conversation. And yes, can I still use this, and how do I use it?
Yeah, and how do I use it? That's another great example of a conversation with the supplier, right? This isn't a, oh, your malt is bad kind of conversation. It's like, okay, yeah, I noticed that these are normally 90%. Today it's 75, or this batch is 75. Hey, what's the deal? Like, what happened to this batch of malt? What do I need to do differently? It doesn't mean that the malt is bad. It just means that you might have to do things differently with it.
Right. And again, you totally nailed it with the conversations. If you're not having those conversations and you're not looking at your data, you're not going to get through this. I mean, it's kind of like, if I've committed a crime, and anybody listening will say, yeah, that's likely. But, if I need to represent, I'm not going to win. If I have to represent myself in court, if I've talked to no one and I just go in there thinking I know everything, I'm going to jail. I'm going to be planning my last meal. Whereas if I hire someone who's got a great pedigree, went to a great school, whatever, and they're going to get me out of this, I've used all the tools that I need to be able to assess the situation and get through this. It's kind of the same sort of thing. If you're not talking to people and you're not looking at your data and understanding what it means, you're not going to, be making the best thing that you could be making. You might be making something, but eventually there will be an issue and you won't understand particularly how to solve it potentially.
Yeah, exactly. How to solve that information. That's a whole separate conversation that we'll get into and touch on probably throughout this whole episode, right? If you've got an issue or problem with your beer and you're trying to solve it, but you don't have the data that you need to be able to solve or to make reasonable conclusions, it's going to be so much harder. You mentioned, so like below 80% might be an indication that something is, changed. It might be an unusual friability number. What's kind of a normal friability number? Is there a normal, or are there ranges that like brewers should look at and go, okay, wow, yeah, this malt was low friability. That means I need to do something different. Maybe I need to change my mill gap or something like that.
Normal is relative, I would say. There are specs, yes, that are put out by BA and by AMBA, that we should expect malt to be. But there are, of course, ranges. Again, going back out to the maltsters who, the farmers and the maltsters in the West who, because of drought conditions or hotter conditions, may have higher protein malts, they might not ever achieve a high friability because of that. Whereas, normal is very dependent on where you're at, what variety you have, how it's been malted, and what you're really going for. In the high protein case, it doesn't necessarily mean it's not modified. So those are other things you have to understand, right? You have to understand like what it means. Okay, if this is 80% friable, does that mean it's high protein? Does that mean it's high moisture? Or does that mean it's under modified?
I see. So yeah, and of course, if it is under modified, that means that you're going to have to do some, different things with your mash. Like if it's under modified, that means it's got lower probably amylase or beta amylase activity, which means you're probably going to want to do a lower mash temperature to help offset that, right? So this is one of those indications that you can look at. If my friability is less than 80%, then I need to maybe mash at a lower temperature, right? That could be a takeaway from this. But again, like you said, it's looking at the other aspects of the malt COA to paint the full picture. Not just looking at one thing, not just looking at friability. That actually is a great comment that we need to spend a little bit more time on. Taking a single data point off of the malt COA isn't going to help you a lot. It's going to help you in the one thing that data point measures, but the malt COA needs to be taken together. I want to spend a couple minutes talking about that, and we'll do that right after this break. One of the biggest improvements to my brewing practices was the upgrade to stainless steel, and Delta Brewing Systems offers some of the lowest prices on high-quality stainless gear, like the Firm Tank, which holds 8 gallons or 30 liters of wort, comes with a domed lid to reduce the chances of a messy blow-off, and it can hold up to 4 psi of pressure. Delta Brewing Systems also has their own line of brew kettles, as well as one of the lowest-priced all-in-one electric brew systems out there, and their prices are remarkably affordable. If you're in the market for legit stainless gear that won't break the bank, you've got to check out deltabrewingsystems.com. One of my favorite beer styles is Kolsch. It's one of the styles that I've brewed the most, and I spent a lot of time perfecting my recipe. And the recipe that I have now is actually over 5 years old. And so Harmonie, one of the things I'm curious about, have ingredients changed in 5 years? Like, for example, my malt bill in this is 95% Pilsner or pale malt, and then 5% wheat malt, white or red. But those are just percentages, right? Those aren't like, I'm sure things have changed in the last 5 years. The percentages might hold true, but the actual amounts, if I were measuring in amounts, would certainly have changed.
Yeah, things have changed, of course. I mean, if you think about even, going back to the breeding thing, it takes 8 to 10 years to develop a variety, and in that time, I mean, I'm just going to say it, climate things are definitely changing. Our targets change. Things do change. They change season to season, variety to variety, year to year, whatever. And one thing I think we can take away from previous podcasts, with you guys and like Glenn Fox at UC Davis and Pat Hayes, is that we need to understand those breeding targets and understand the implications of those breeding targets and understand the impacts of climate changes on those varieties. I was just looking, I think Proximity put out I think it was on LinkedIn or whatever, a map of drought conditions this morning. And, in the past 3 years, they've really changed. Things are constantly changing. And that a variety that was developed 5 years ago may be responding differently. Not only with disease pressures, but in protein carbohydrate content. And if you recall, Glenn Fox talking at the conference about gelatinization temperatures, those are changing as well, and something we need to keep in mind about potentially, we need to keep bringing that up as a point of needing to monitor those.
Yeah, that's interesting, right? Like the gelatinization temperatures of the malt itself. So that's, again, like opening up the starches so that the enzymes can even access them, to turn them into fermentable sugars. That's changing. And that's something that's not currently written on a malt COA. And that was one of the comments that Glenn was talking about. That might be something that should be added to a malt COA for reasons that he and his lab are studying. And so all of these things, right? All of these data points on a malt COA, they're intended to paint a picture of the malt quality. They're obviously not the whole picture, but they certainly aren't meant to be isolated. Like, for example, friability isn't the be-all, end-all of malt quality. It's not like we just, okay, I know the friability done. I've looked at my malt COA, right? The more numbers than just one thing are important on a COA.
Yeah, absolutely.
Cool. Yeah, good. Done. Nice. But yeah, I mean, we were talking about this at the ASBC conference, and I think you gave a good example of this where you were talking about like going to the doctor. If you go to the doctor, they look at you as a whole person, right? They look at your medical history and your whole person. They're not just looking at you when you come in for whatever, right? Like it came in because your finger is hurting or something, or you've got a runny nose. They're not just going to say, oh, well, you've got a runny nose, this is the solution, right? It's like, well, what's your medical history and what's going to work for you? Maybe allergies, it might be a virus, it might be something else, right? We need to look at you holistically. Same thing when a malt comes into your brewery. You don't want to look at just friability or just extract potential and then throw the malt COA in the trash. You need to look at the malt and assess it and understand it. And the quote that you gave me, and I'll never forget this, is you said, malt wants to be seen too. So I love that quote. And so anything, is your opinion on that changed or no? Still a good example?
No, it is a good example. And, one of the things that, my predecessor, Aaron McLeod, often said was, we really need to understand the personality of each malt, of each barley, really. Each barley variety has a unique personality. And from year to year, we need to really keep those things in mind as we malt and as we brew with these things.
Yeah, absolutely. Things change. The malt itself wants to be seen and understood so that you can brew with it. All right. Well then, okay. So number one most important on the malt COA for you was friability. What about number two? What's the second most important item on a malt COA?
Boy, I'm going to say assortment. And so assortment. It plays a critical role in the brewing process. It tells you how to set your mill, right? And I know a lot of brewers hate to do that, but it's critical. Your extract losses in brewing when you're using a water ton are frequently related to your mill settings, especially if you've got a 2-roller mill, which can't be set to, ideally grind multiple kernel sizes correctly. A wider assortment makes it more difficult to set your mill. There are also a lot of differences in assortments between 2-row malts and anyone using a 6-row malt. I know not a lot of brewers do, but some do, due to the kernel size differences. 2-row is more plump usually than 6-row. So
So what is assortment then? Is it like a measure of the size of the kernel, or what is assortment?
yeah, so it is a measurement of the size of the kernels, and they are measured on four different screen sizes: the 7/64th, 6/64th, 5/64th, and then the less than 5/64th. So it's like plumps and thins, and of course you want more plumps, right? But a wider assortment, like I said, say you've got ideally maybe you want 95 and above percent plumps. But if you've got a wide range, like you've got, I just mentioned those four screen sizes, if you've got, you know, 80% on the 7/64th and then, 10, 10, 10. So I don't know. I didn't make any sense with that, but you know what I mean? If you've got a very wide assortment, it's going to be hard to capture all that when you set your mill. Whereas if you've got a lot of plumps, you can set that mill appropriately to capture all of those and you'll have, a little bit of variation in there, but not much. And because the 6 row, it grows on the stalk, it varies in its size. So there are even more issues with those assortments. There's a much wider range, and so people have a difficult time setting their mill to that. And so you don't capture all of that. You won't. It will crush very differently, right? And you'll get a variable extract.
Oh man, this one makes so much sense to me. I mean, I've several times I've been asked this question from homebrewers. It's like, I'm not hitting my OG, I'm not hitting my target gravity, and I consistently can't do it, and I don't understand why, or I'm not hitting my efficiencies. The numbers coming out of the mash aren't looking as great as they should, right? I should be getting 85 or something percent efficiency, but I'm getting 65. And I always tell them the first place to look is your mill, right? Because that's going to be, for at least most homebrewers, that's going to be where most of this is happening. It means that something is up with your mill. You're not getting a good enough crush to be able to expose all of the starches to allow the enzymes to work on those and make fermentable sugars. So I can see this, right? Assortment is plumps and thins. So you want plumps because when they go through the mill, they go crack, right? But if you've got a low percentage or a high percentage of thins, a low percentage of plumps, those thins are just going to make it right through, and you're not going to get full conversion out of those. They're just going to make it into your mash, but they're going to be basically essentially the whole kernel with the husk and everything on it. It's not going to crack open, and you're not going to liberate those starches. Is that a fair assessment of like assortment?
Yeah, that's pretty fair. Yeah, absolutely. And again, I realize that it's a pain in the butt for some people to adjust their mills, or people just don't like to do it. But having a consistent and uniform size distribution, is really important. So, you want to present the mill with the same assortment of particle sizes for as long as possible. Looking at that COA and understanding what those assortment values are is really important. And, the biggest changes happen when there is a crop change. So, there will be different size kernels based on growing season, variety. You've got to compare your COA pretty consistently to get the most out of that malt.
That's interesting. So, okay, so let's sort of take some like a high level assessment of assortment. And so like, again, we want more plumps, like that's the 7/64ths, and we want fewer thins, which are like 5/64ths, are making it all the way through the 5/64ths. It is like, let's say I get a batch that is well, let me ask this question first. What's a low percentage of plumps, for example? Like, where would that be?
So plump value should ideally be around 80%, and the thins should not exceed 3%.
Okay.
Ideally.
And when we're talking about thins, are we talking about that 5/64ths number or the falls through the 5/64ths?
Yeah, the falls through.
Okay. And so we want around 80% plumps and less than 3% through 5/64ths.
Yeah.
Okay. So then, if I've got around 80% of my plumps and I've got less than 3% of my thins, how do I set my malt? Just like set it like my normal mill gap, or finding out whatever gives me the best grain crush for my mill. I mean, that's obviously going to be dependent on the mill. But then what if that changes, right? So what if I've suddenly got 75% and then or more thins? Like, what do I need to do? Do I need to tighten my mill up if I've got more thins, or how does that work?
Yeah, that's a great question. I am not a mill expert.
Fair enough. Yeah.
But I mean, but you were right with what you said before. You need to, and it might take some messing around with that to figure out what the best mill setting is for what you've got, and that might, the assortment, it might vary batch to batch too. So keeping that in mind, that it might not always be, like 80% exactly or 75% exactly, keeping that in mind for the best crush that you can possibly get to get the most extract out of it is really key. And there's gonna, it's unrealistic to expect perfection from that. You're gonna get some thins that fall through, and you're not, you might get, a little bit of flour in there based on your mill setting, but it really does take a little bit of experimentation. I wouldn't say there's one right answer because, again, the crop year change and, different varieties yield different. It's not like every single variety will, yield, the exact same plumps and the exact same thins.
Yeah, totally. That makes sense. So this is, again, kind of like another indicator of a change, right? That's happened, right? If you're normally seeing around 80% in your plumps and suddenly you get a batch that's 70%, or suddenly you get a batch that's 90%, right? Like you know now, okay, hold on, I need to make a change to my process, right? Because this batch that I've got is now different than what I'm used to brewing with. And like you said, right, 79, 80, 81, 82, 78, anything in that range might not actually affect your process. It might, depending on your mill, but that's something that you might have to play around with. So there's not like a magic number of assortment that works for everybody, right?
No, not at all. It's really just back to that thinking, how do I avoid a situation that leads to difficulties down the road for me? Performing that grist analysis is really important. I mean, it's one of the first things that we used to teach students about. You're going to run into trouble if you have pulverized your grain, and conversely, if you haven't broken it up enough. And I would encourage those conversations between, maltsters and brewers or distillers or whomever about the crop year changes or variety change when you're looking at that.
Yeah, and I guess one last question. So does assortment change pretty significantly? Can it change significantly between harvest years and lots?
Yeah.
Okay, good. So that's another one to look at. All right, so that's 2 down then. Friability and assortment. What's then the third most important number on the malt COA?
I would say free amino nitrogen.
Oh, FAN. Okay, let's talk about free amino nitrogen then. So what is FAN? What is free amino nitrogen? This is a great one because I've been wanting to talk about this one for a while.
Yeah, so free amino nitrogen, it is all of the nitrogenous sources, including the amino acids that are required for your yeast nutrition and your proper fermentation. It forms during the malting process and is correlated with soluble protein. And your FAN targets, that depends on your system and your requirements. For all malt brewing, you want below 200 ppm. And I'm sure that Campbell will email me after he hears me saying that. But
how much do you want, Campbell? If you hear this, let me know and I'll read it in as feedback, or get you on to talk about FAN. So yeah. Yeah. All right. So you said it was correlated though to soluble protein. That's important because soluble protein's a measure of amylase activity or enzyme activity.
Nope, soluble protein, that provides the basis for your yeast nutrition and your foam retention. And that is influenced by the amount of total protein and the degree of modification. So I just sort of another measurement, a very important measurement though. That's the amount of protein that's been broken down and is soluble and available in wort.
So then FAN is also a yeast nutrient, right? Yeast needs it or wants it for fermentation.
Yes.
Okay, and so that's why you want to hit that around 200 parts per million number for FAN whenever you get into a fermentation.
Yeah, I mean, and again, it depends on, and I know I said this about the other metrics as well, but it does depend on your system and it depends on what works for you. If you are feeding your yeast, a malt, if you have a malt that is consistently 150 ppm, and then all of a sudden you get a malt that is 70 ppm or one that is 250 ppm, there's going to be some very different outcomes.
Mm-hmm. Yeah, and I would guess like lower FAN would mean more stress on the yeast, right? Like so the yeast doesn't have the nutrients necessarily that it needs.
Correct. And if you do, have something that is lower than what your yeast are used to, you may need, a yeast nutrient.
Ah, okay, yeah. Oh, so this is another great one too, right? If you're seeing some issues with fermentation after having, brewed a batch with this malt, it could be that the fan was off, and maybe you needed some yeast nutrient in this batch. There's an interesting commentary there too. We've done a lot of experiments on yeast nutrient at Brewlosophy, and granted, most of those are with fresh pitches of yeast, so we're not talking about propagated and repitched yeast, which are going to be much more reliant on the fan that's contributed by malt versus like yeast that's from a lab, which is supplemented with everything that it needs whenever you pitch it. But we've done a number of experiments on that, and it's always sort of come back that the yeast nutrition didn't seem like it was having an impact. Like there were not significant differences, but that, again, could be for two reasons. One, we're using fresh pitches, but two, could also be that the malts we were using had high fan in them and had enough fan that even if we had been repitching yeast, we would have had enough fan and the yeast would have just done its thing without even noticing.
Yeah.
Yeah. That's interesting commentary. So fan, all right, so then I'm going to start thinking about fan. I'm learning something new today too, as a yeast nutrient. And so this is important for your fermentation issues. Now, if you have low fan, you might want to add some yeast nutrition, but is there such thing as too much fan?
Yes. And again, that depends on your system, your yeast, the product that you desire. I mean, remembering that the exact components of fan do vary.
Sure. Yeah. That's just free amino nitrogen, right? So there's a lot of amino nitrogens out there. Yeah.
Exactly. It's all over the place. And one of the things that people like Patty Aaron and Zhang and I, and a lot of people, and Glenn Fox, everybody, talk about is that varying composition in the wort. All 21 amino acids are found in trace amounts, arginine, proline, and glutamine being the most abundant. And Glenn Fox will definitely fight me on this one, but normally our yeasts, our common yeasts, cannot assimilate proline. So think about the fact, that you've got all of these varying amounts in each wort of these amino acids, and your yeast is eating these preferentially, right? Like, the rest are pizza, and the proline is like its little broccoli. It wants it last. And all of these amino acids go on, well, they are precursors to flavor development, right? So if you've got, a certain level of arginine, a certain level of proline, whatever your levels are, those are going to create some very different outcomes. So overabundance of fan might mean that the yeast isn't going to even consume all of that. So you're going to have all of these leftover amino acids anyway that are going to be making all of these potentially off flavors.
Interesting. Beer. Yeah. So it is, and there's not necessarily like a breakdown of free amino nitrogen. That's not on the malt COA. It's just going to be like a total number of free amino nitrogen. But if you have too much, right, you can have a lot of alternative flavors that are being added. That also could be an issue, right? If you've got some weird off flavors in this batch of beer and you don't know what it is, I mean, and you look back and you had a free amino nitrogen of 400 or 500, then hey, yeah, maybe you've got something going on there. Now, hopefully they're not going to sell you a malt that's 400 or 500, I would guess. I think that's pretty high if I was guessing.
Yeah. That would be wild. That'd
be wild, right? But, maybe 250 or 275 or something like that, and then who knows what those are actually gonna do to your beer. So, all right, that's three different things on a malt COA, and we haven't even talked about extract potential yet. That one was the one that I think most brewers would look at and go, or maybe not most brewers, but maybe most home brewers would look at and go, well, I think that's the one I would need, right? That tells me what my OG is. But you can't really assess extract potential without looking at the rest of the malt specs, right? Without looking at the assortment and knowing what your mill size is, and looking at your friability, and then of course the free amino nitrogen for the yeast health and stuff. So extract potential is kind of down the list, right? It's kind of like the one that it wasn't as important. It's not at the top.
No, it's not. I mean, it shouldn't be at the top, but it is important to understand. It has a negative correlation with protein. So, you can kind of learn a little bit right there. The more protein, the less starch, the less extract. Extract itself is the total soluble content of the malt that dissolves during mashing to produce wort. It's a function of grain modification and enzyme activity, and an indicator of potential brewhouse yield and performance. So both over and under modification in the malt house could change or reduce your extract.
Right. That, and of course, what you're doing with it in the brew house, right? The different mashing conditions that you're putting it under. I think this is one of those things that hit home to me, is that there's this distinction about like the mashing regime that you use to calculate this number. My understanding is it's a European Congress mash, which is a step mash. Most brewers, at least in the United States, are using single infusion mashes, and that's a very different mashing regime and could result in different numbers. That's not even getting into this whole distinction between fine grind extract and coarse grind extract, which actually I am going to stop there. I'm going to ask you a question about that. What's the point of fine grind extract? Because fine grind is like, if you make flour and then you mashed flour, this is the amount of extract potential you'd get out of it. But nobody's doing that. So why do we even have fine grind extract on a malt bill?
That's a good question. You're right. The fine is more like a flour, with the coarse being more like what a brewer would typically mill to. Fine grist do allow for a higher extract value, as you're allowing that water to get to all the internal parts of the malt. Coarse grist can give a slightly lower value, but are more representative of what a brewer experience. It's just sort of that highest predicted value. It's a good question. I think that all the time, and I think about that all the time, because I'm a total dork, and I do wonder why we haven't honestly moved to reporting more realistic values. And what you just said about the Congress mash versus the infusion mash is totally true. The Congress mash, it's from the 1970s, and not that means anything. I'm from the 1970s, and I seem to be okay, but
right.
It's just completely different than what we use. And, we've done a bit of work on this, and the values really do differ. But, Mary Jane Maurice was actually just on an MBA podcast talking about this as well. It's really going to take an all-in from the industry to say, hey, we want representative values, because this is something that we've all talked about, is, changing up these metrics to represent what really goes on in a majority of the brew houses today.
Yeah, so it's kind of like fine grind is kind of like the aspirational malt extract value, right? It's like if you can get this is the maximum amount that you'll get out of this, but you're probably only going to get coarse grind or something around that. All right, well, so that's extract potential. We couldn't talk about a malt quality COA without talking about extract potential. But of course, there are all kinds of other numbers on a malt COA, and we don't have time to get into those. There's moisture, beta glucans, diastatic power. Oh, color. That's a big one for malt. S&T ratio, soluble protein over total protein. All of these different pieces of information that are on a malt COA. And unfortunately, we don't have time to get into all of those today. But I did want to reiterate the comment that we were talking about earlier. And that's that these things don't exist in isolation, right? Extract potential, friability, assortment, they don't exist as isolated numbers. They paint a whole picture of the malt. And there's been this theme that we've had going through the whole show, which is talking to your supplier, talking to your maltster, about the malt, right? So if you're looking at friability and you're starting to notice some things that are off, or if you're looking at assortment and you're starting to notice some changes in the way that the malt is coming to you, these are conversations that you can have with your local homebrew supply. These are conversations that you can have with, your ingredient supplier, the, BSG or whoever is supplying the malts to you. And if you're big enough, also you can talk to direct, maltsters and farmers about like what you want your specifications to be. So these are all great examples of reasons why and to have conversations with maltsters, right, Harmonie?
Yeah, absolutely. And I wouldn't even say big enough I feel like, especially our craft maltsters and our farmers are very open to having conversations about, what goes on in the field, what even, went on to produce this barley that made this malt. What are the conditions, from, seed to being malt. People are very open to having those types of conversations. You know, the craft maltsters are out there experimenting with varieties and promoting regionally adapted sustainable varieties. So, you know, if you're someone interested in local, you know, flavor, for lack of a better term, I've stopped using terroir, but, you know, I would support your local grains and malting production. Go have a conversation, call these people up. They love talking about their process and their malt, and they're more than willing to sell it to you and to teach you how to use it.
Yeah, absolutely. And they improve by hearing feedback, right? From hearing feedback from brewers about malts that you like or don't like, or things that you want to do. Same thing, even though home brewers often feel like they're, you know, the small person in the room, they have a ability to talk about these things as well. Talk to your local homebrew supply, talk to you know, the suppliers who supply the local homebrew supply, and you know, you can get the kinds of malts and things that you want. But the main takeaway for me is look at your malt COA. But I want to ask you, Harmonie, what is your main takeaway? If we want brewers to take away just one thing from today's episode, what would it be?
I think that, well, yes, everybody should read the COA. But I think to parrot Mary Jane Maurice, you know, brewers should really understand malting. It's something we've obviously been trying to push and educate on. If you don't understand the basics of malting, or why malting, or, you know, the reactions of, you know, malting, you won't understand the oppositional specs or how to communicate your needs to your supplier. I understand that brewers get really fixated on points on something, but those are moving targets, and they do change. And, you know, in our system, there is allowed some flexibility for that. Again, you know, you're not going to get the same thing from, you know, if BSG as you're going to get from Admiral out in California, as you're going to get from Valley Malt out in Massachusetts. So I would just, you know, try to really understand the malting process and how these things come to be, and truly try to understand what the COA means and what it means to you and your process.
Yeah, I think that's great. And then there's actually just one other question that I would ask, and this is springing this on you, so you're not going to be prepared for this question, but it's maybe some homework for you. Are there resources out there that brewers can look to for looking for more information about malt quality?
If they're looking for more information about malt quality, there are tons of resources. I feel like, well, number one, a good place to start is your supplier's page. You know, like Breeze or RAR or whomever, they all have those little informational, at least web pages about, you know, what these specs mean. And they give ranges, they give ideal ranges. So that could at least get you started. But you know, there's also the Craft Maltsters Guild. If brewers are looking to be educated on that, you know, they do offer webinars and classes on the malting process, if that's something that people really wanted to get in depth into. You know, if they just have basic questions even about things, I mean, they can call me up, they can call Hannah up. You know, there's a lot of people that people could call up, but there is a lot of information, you know, online about where to go to ask those questions. And I wouldn't be afraid to ask those questions. It's really important to understand. And I know a lot of us, you know, you feel stupid asking those questions. You feel like, you know, as a brewer, you should know, or something like that. Yeah. But, you know, we don't all know everything. So it's, again, just reiterating that it's important to have those conversations. Yeah.
Oh my gosh. Yeah. As the longer I do this, but this is episode 126 of the podcast, or 124 of the podcast, 124 different brewing science episodes. And all it has told me is that I know very, very little about brewing beer. But in any event, so awesome. And those are great resources, fantastic resources. So if you need more information, check out those places that Harmonie just mentioned. Is there anything else that you wanted to talk about with respect to malt quality that we didn't get to today?
Don't blame the malt.
Don't blame the malt. Oh man, we totally didn't talk about that one at all, but we should have. Yeah. Maybe we'll leave that one right there. Don't blame the malt. There are things that you can do to work with the malt as well. And maybe it's not the malt's fault. Maybe it was you not, or ignoring some malt quality information. So, well, cool. Well, Harmonie, thank you so much for joining me in the Brew Lab and continuing this awesome discussion about malt quality. And I hope to have you back in the future.
Yeah, thank you so much for allowing me to come back for a third time. This has been great.
All right, well, great. Well, all right, next week, Jordan and I will be back applying the science of this episode. See y'all then. The Brew Lab is a production of Brewlosophy, where they who drink beer think beer. Don't forget to visit brewlosophy.com to read about our weekly experiments and other brewing adventures, and listen to us talk about it on our other show, the Brewlosophy Podcast. Thanks to all of our sponsors and patrons that help make this show possible. If you'd like to receive a reward for helping us do what we do, visit patreon.com/brewlosophy to see how you can do just that. Thanks so much for listening. We'll be back in the Brew Lab with another guest next week. Until then, think beer.